Rational expressions are a relatively minor ACT topic, shows up on a little bit less than half of tests. It's a good point to get, and it's a good thing to practice just because the skills that you use in rational expressions are really helpful elsewhere, and it's another way to take a look at things like factoring, which is so important, and some fraction skills. Let's take a look at the problem I have up here. Now, before we get into the problem, let's talk about the statement that the question makes. By that, I mean assuming x squared minus y squared does not equal 0. X squared minus y squared does not equal 0. This is a perfunctory statement, kind of like when they define I for you as a complex number. It's something that's, I guess, necessary to tell you, but it has no bearing on how you're going to solve the problem. Why do they tell you this? Well, because if x squared minus y squared is 0, then this whole expression will be undefined. This whole fraction will be undefined. So if you have a single variable rational expression, you'll have something like this a lot of times. X has to be greater than 3, or X has to be greater than 21, just to remove any possibility of having a 0 in the denominator. Rational expressions, as a definition, all they are fractions involving variables. Rational numbers are numbers that can be expressed as a ratio fraction of two integers, and expressions are just mathematical phrases that have variables in them. All right, let's get started. Now, if I see a quadratic on the ACT, automatically think factoring. It's like shooting from the hip. I'm automatically already thinking factoring as soon as I see that x squared. So let's start there. X and x. My signs will be positive. Positive n means they'll be the same sign. Positive, positive, negative, negative. Positive middle means it's positive, positive. Two numbers that multiply to 3 add to 4, that'll be 3 and 1. And I need to dump a y in each one. If you're not comfortable with factoring, particularly the fact that we have these two variables going on, check out the videos on that and the material on that, because I cannot overstate how important factoring is for your ACT math success. All right, so we got that factored. Let's go ahead and drop this in here as well. Just finish rewriting what they gave us. Here's where a lot of people are going to get stuck. Now, you got to remember, you can't cancel things out that are being added and subtracted, only multiplied and divided. So I can cancel out nothing right now because I don't have an x squared minus y squared in parentheses up there. Before, when I had the x squared and the y squared, I can't just cherry pick and say, well, that one's gone and that one's gone and this one's gone, and I'll just leave a 3 and that one's gone. It doesn't work that way because I'm adding. These guys are involved in addition. Now, if I had an x minus y, I could do that, right? And I can test and see if x minus y is a factor of x squared minus y squared. I'll get to that in a second. But I can't just say, well, there's 2 of these x minus y's, because there's not. X squared minus y squared is not the same as 2 times x minus y. So I can't just pull the squares off of these and cancel that out. To be very careful. Factors. It's got to be identical and it's got to be bracketed in parentheses because this is a single thing. This is a single quantity, you can say. And I can only mark it off. I can only simplify it if I can match it up with something that's the exact same. So on the bottom here, you have something that doesn't automatically look like it'll factor unless you're really familiar with your factoring and you remember difference of squares. That's covered in the intermediate factoring video. And it's definitely worth going over if you are uncomfortable with it or unfamiliar with it. Perfect square minus perfect square will always factor into square root plus square root times square root minus square root. And that's it. Now, if you didn't see that, but you had the premonition that these things would factor, you could try this as a factor of that by dividing the binomial into this, or by back solving using one factor to find the other factor, which is something I cover in the intermediate factoring video and in the material. But by and large, and this is a little bit of an exception because we had the difference of squares on the bottom, But by and large, what you're going to do is you're going to take the binomial on the top and test it as a factor of the quadratic on the bottom. And if you have a binomial on the bottom, which is more often than not the case, you'll test it as a factor of the quadratic on the top. In the case, assuming that these are hard to factor, and sometimes they will. They'll give you coefficients from your x squared term that aren't 1, and maybe they'll have mixed signs and large numbers. So if it looks hard to factor, then test the opposite binomial. If you have a hard one to factor up here, hard quadratic, test the binomial on the bottom as a factor of it. That can help you find your other factor really easily. So I've already done all this because I knew my difference of squares. I don't have to go back and test anything. So now I can just mark off this stuff that's alike. X minus y, parentheses. That x minus y, all it's doing is being multiplied. That's a factor. Only mark off factors. X plus 1y, that's the same as x plus y. And I'm left with an answer that's x plus 3y over 1, or just x plus 3y. Generally, by the way, these will tend to work out to really simple solutions. It's not uncommon for the solution to be like 1 or 2, or a simple binomial like this. So they typically cancel out pretty nicely. There's another type of rational expression question that's more conceptual, and it has to do with some of the nuances of simplifying fractions and what you're allowed to do with fractions. I didn't feel like it was a good place to cover here, or a good thing to cover in this video, but I do cover those at length and have practice problems for those in the book, and I really encourage you to look at them. This is sort of the standard, been around forever rational expression question, and it's still the somewhat dominant one. You see it somewhat more frequently than the more conceptual type. But the more conceptual type has become pretty popular in the last few years. So if you really want that top score, make sure you spend a little time on it. These are good points to get. These are good points to get. They're very achievable points, and they're skills that apply elsewhere.